Alright, last video for Module 4. Welcome back to ECE 382, can't forget that, and I hope you guys are having fun. This should be a quick one on debugging. So you've already done debugging, so you've done that in Code Composer Studio, adding breakpoints, continuing, stepping into, stepping out, looking at different variables. But let's talk a little bit about what that is. When you're debugging, what is it that you're actually doing, and then kind of some more of the concepts behind that. So functional debugging is what we do to test a specific functionality of a system. So for example, if we just wrote our bump sensors, we would be testing that system by looking at the bump sensors, pressing them, looking at the values of the port, seeing if do we send does the correct logic occur? Does the system send a, hey, there's a bump, do something kind of message? So there's two main components of functional debugging: control and observability. So first we have to be able to control what the software executes. So for example, if we're just testing the bump sensors, we don't want to necessarily have the robot drive for 10 meters and then hit the bump and hope that it works, because if it doesn't work, then we're going to just continue just driving into a wall. So we're going to control what software executes. So let me just rewrite that so it's a little bit more concise. We're going to control what software operates or executes. So maybe we're just reading values from the ports that are connected to the bump sensors. And then we control what inputs are provided to the system. So we'll see this next time when we start testing our equation that we're going to use for our distance sensors. So we're going to provide it input values. So instead of using the real system to test our equation, we're going to test the equation by itself, the equation that's going to take the hardware, the sensor data, and convert that to actual distances. We're going to test that equation, that conversion by itself, using controlled input values. So we're going to provide it an array of values that we know we know what the result is. And so that's what we're really talking about when we say control what inputs are provided to the system. So I can provide it an array of values that I know the result. Now I can test my equation, make sure everything's good. So observability is to make sure that we can see the results that are occurring. So for example, if something's happening at a microsecond speed and we expect to see that with our eyes, it's not going to be observable. So we would have to maybe either slow down the system or record the data and then go back and look at it later. So we have to be able to observe the inputs. So it's going to observe the inputs, so we're going to see what's going into the system. We have to be able to observe the outputs, and then observe what code is running. And that's where the debugger really comes in, stepping through, going and seeing, hey, what line of code is running. And so when we can do those three things, then we can really see, hey, here's the input, here's the code's running, here's the expected output. And that allows us to then have that observability and really know what we're our system's working how we think it is. So now that we have control and observability, we have to design our test cases. So there's 4 main ones that I want to talk about. So the first, near extremes, and in the middle, this is called edge testing. And sometimes, and we'll see this with our when we start designing the controller to figure out, hey, do we want to turn left, turn right, go straight? There's going to be thousands of sensor values we get from the distance sensors, but we're not going to try to test all of those. It's going to take hours to do that. So we're going to test our edge cases, so our extremes and in the middle. We can test what's going to be most typical of how clients will use the system, properly use the system. But if we want to have very robust systems, we also need to test most typical of how clients will improperly use the system. In these two right here, there's lots of studies, there's lots of math, statistics. How do we know if we tested it enough? This is a whole career field. That's some of what your friends are doing over in the operations research kind of stuff, OR. So this, how do you design a good test case? In the test, my first job was a test engineer. How do you prove that the system's really working? So this is, like I said, there's just an entire science behind all of this. So this is just, top level, very general sense. So my test cases I'm providing you are not exhaustive. All right, and the last are your corner cases. So a point where there's going to be a change in output. So for example, if at 100 millimeters, we're going to run into a wall. So our distance sensor sees a wall at 100 millimeters, it's going to stop. Okay, so then we want to check 99, we want to check 100, we want to check 101. So if that seems like, if those three values work, then we can get an idea that, hey, before here we're going, and after here we're stopping. So how do we control test cases? So we can use an array of values. So like I talked about, that will be input into your function. So that's where we talk about that conversion. We're going to use an array of values that we know the output, so then we can just check and make sure it works. We can use a file, and then sometimes trial and error. And this, when we get to the final project, when you're going through the maze and it seems to drift left, and this is just where it comes trial and error. And that's because of the physical nature of what we're doing. All right, so we've used the debugger already, so I'm not going to go into a whole lot of detail for these, but goes line by line. Skips function calls, goes into function calls, and then we'll run rest of function. Without stepping through. So in case you got into this point and you don't know what the debugger is doing, this is what it's doing. Breakpoints allow us to stop and look at, that provides us that observability. We can stop, look at all of our variables, expressions. And then a test main is a main that instead of just running your function, main that instead of just running your program, a test main establishes the exact scenario sometimes I can't write you want to test and provides stability. All right, so that just allows you to, instead of going through and just running your motors and doing just driving out through the maze, a test main would say, okay, we're going to go straight, then left, then right, maybe. All right, last little section, how do we observe values while debugging? So there's 4 different ways. The monitor windows, which we've seen through the debugger. So that's our global variables, registers, etc. We can use a memory dump, which is basically saves results in RAM or ROM. And that's helpful if we have our robot disconnected from the computer because it's going through the maze. We can use the dump to save values into a register, or sorry, into memory, and then we can plug it into our computer. That memory will be somewhat preserved, and we can look at it through that. We can output to a UART. And we'll talk about UARTs, and we'll see that for sure. And then we can add an LCD or other hardware monitors, and that's going to be our primary form of observability once we have the robot driving around. All right, so that is debugging. So lots of things in there, along with how do we control our debugger, how do we observe what's going on, and then how do we tie that all together to test our system. All right, with that, that's all the videos, hopefully for Module 4. Pre-lab's due next time. Nope, sorry, pre-lab was already done, but you're going to be continuing to work on the lab. Day 2, it's all one part, but I'll give you a few days to work on it. So, see you next time.